What would actually happen if you fell into a black hole? Not the simple version, not the one you've heard before, but the real physics and the terrifying unknown. Let's go deeper. Imagine you are floating in space, drifting toward a black hole. At first, it doesn't look like a hole at all. Instead, you see a perfectly dark sphere surrounded by a glowing ring of light. But something feels wrong. The stars behind it look distorted, bent, as if space itself is being warped. This is because a black hole doesn't just pull objects, it bends the fabric of reality itself. As you move closer, something strange begins to happen to light. Photons, particles of light, start orbiting the black hole. There is a region where light can actually circle it. This is called the photon sphere. You could, in theory, see the back of your own head, because light is looping around the black hole. Now you're getting closer. Gravity is becoming extreme. But here's something most people don't realize. If the black hole is large enough, you might not feel anything when you cross the event horizon. No sudden force, no dramatic moment. You simply pass through. And that's what makes it even more terrifying. Because at that point, you are already lost, completely. Inside the black hole, space and time begin to switch roles. The direction forward in time becomes the direction toward the center. Just like you cannot stop moving into the future, you cannot stop moving toward the singularity. It's not just difficult to escape, it's impossible. Not because something is pulling you, but because all possible paths lead inward. Now, let's talk about something even stranger. Time. From the outside, an observer would see you slow down, more and more, until you appear frozen at the edge. But from your perspective, time feels completely normal. This creates a disturbing paradox. From the outside, you never fall in. From your perspective, you already have. Both are true. Now inside, the stretching begins, but not always in the way you expect. In smaller black holes, you are torn apart before crossing the event horizon. But in supermassive black holes, you might survive the crossing, only to be destroyed later. And then, you reach the final mystery, the singularity, a point of infinite density, a place where all known laws of physics break. But here's the truth. We don't actually know what's inside. Some theories suggest that instead of a point, the singularity could be a doorway, a bridge to somewhere else, possibly what we call a wormhole. Others suggest something even more mind-blowing, that information, everything that falls into a black hole, is not destroyed, but somehow stored on its surface, encoded in ways we don't yet understand. This is known as the black hole information paradox, and it's one of the biggest unsolved problems in physics. So what really happens to you? Do you get destroyed? Do you become information? Or do you end up somewhere else entirely? The truth is, no one knows. Black holes are not just objects in space. They are boundaries between what we understand and what we don't. You wouldn't just be entering a black hole. You would be entering the unknown. If you want to explore more of the universe's deepest mysteries, subscribe and join us, because this is only the beginning.